Dear student, today we'll see the hydrolysis of salt. We know the salt means what? Salt is an ionic compounds of the neutralization by base and the acid. Salt is the an ionic compound is the salt or the acid and the base to produce. Now the hydrolysis of salt or salt hydrolysis. What is the same? The hydrolysis means what? We know that the neutralization process. The hydrolysis is the process of reverse the neutralization. Neutralization means what? When the acid combines with the base to formation of salt and the water. Salt and the water. This process is known as the neutralization. Hydrolysis is the reverse of this one. Reverse of neutralization. Therefore, here formation of salt, but reverse means when the salt combines with the water to produce the acidity or the alkalinity solution. Acidity or the basicity solution is nothing but the hydrolysis. Therefore, the hydrolysis is the process of the reverse of neutralization. Our actual definition of hydrolysis is that the process or hydrolysis is the process in which cations or the anions or both the ions are combined with the water to produce the acidity, and the basicity is in the solution is known as the hydrolysis of salt. I will repeat that. Hydrolysis of salt or hydrolysis is the process in which cations or the anions or both the ions combines with the water to formation of the hydrolysis reaction to produce the that acidity and the basicity in the solution is known as the hydrolysis. That is the hydrolysis process. Now, that hydrolysis are the acidity solution or basic solution or the neutral solution that depends upon the that or the due to the presence of the ions. Means here these are the four types of salt. First all is the salt derived from strong acid and the strong base. For example, the sodium chloride is a one salt. KCl, potassium chloride, is also salt. But which salt? That is the strong acid and the strong base. We will explain one by one. But we know first one, the what are the types. Second type is the salt derived from or salt of strong acid and the weak base. For example, ammonium chloride is the salt of strong acid and the weak base. Copper sulfate, then ammonium sulfate. They are the number of example of the salt of strong acid and the weak base. Third type is the salt of weak acid and the strong base. For example, this ammonium, sodium acetate, potassium cyanide, then sodium carbonate. Now these are the example of salt of weak acid and the strong base. And last type of salt is the derived from the weak acid and the weak base. They are the very important four types and the hydrolysis of salt. First, explain the one by one. Now see here the hydrolysis or salt of first one, salt of the strong acid and the strong base. We'll explain first. We know that this is the salt. Which one? Suppose let us consider the sodium chloride is a salt. It hydrolyzes. Hydrolyze means what? Combines with the H2O and the it gives the salt of from the strong acid and the strong base, means NaOH plus HCl. Now this is the strong base and the strong acid. Therefore, the hydrolysis of salt, according to the ionic theory, when that strong salt is dissolved water to produce the Na plus and the Cl minus plus H2O, that gives the Na plus, then OH minus, then H plus and the Cl minus. That are the according to ionic theory. Now this is the product, and product is the strong base and the strong acid. There are number of the ions Na plus, Cl minus and the H2O. Then here product Na plus, OH minus, H plus and the Cl minus. Now both ions are same. Which ions? In a left hand side means a reactant and right hand side of the product. Two ions are same. Which two ions? This Na, this Na get cancel. Then Cl and that Cl also cancel, because the reactant side and the product side, that ions are the same or equal. Therefore, only this H2O is remain. This OH minus ions and the H plus ions. Therefore, in a product or the resultant, the as a resultant product is the same as H plus and the OH minus ions. Therefore, that pH value is the 7, means it does not hydrolyze of salt of the strong acid and the strong base, because according to the definition of hydrolysis, hydrolysis is the definition of hydrolysis is the a process in which the cations or the anions combines with the H2O. But in this reaction, or that salt reaction, that not contain the ions, whether the cations or the anions, only that H2 is remain. H2O that gives the OH and the H plus ion, and according to the definition, not combines with the cations and the anions. Only H2O, that is unionized, remains same. Only this pH of the solution is the 7, and therefore the salt of strong acid and strong base does not hydrolyze. Now, this is about the first salt. Now, sometimes in your annual exam, there is one question which carries the 2 marks. Explain or the why the salt of strong acid and strong base does not hydrolyze. And that is some of the example. Sorry, explain about this first salt or salt of strong acid and the strong base. And around that example also, which carries the marks. Then another one, the salt of strong acid and the weak base. Now, let us consider suppose the salt of the strong acid and the weak base. For example, ammonium chloride NH4Cl is the salt of strong acid and the weak base. Now, according to the definition, this is the salt combines with the H2O, means it hydrolyzes, combines with water, then it gives the formation of the NH4OH and the HCl. HCl. Now this is for the weak base and this is for the strong acid. Means that the salt ammonium chloride is a salt of the strong acid and the weak base. Means formation of ammonium chloride, it is the formation of ammonium chloride is the combination of strong acid, that is the HCl, and the weak base ammonium hydroxide. Now we know this according to the ionic theory, same procedure here. The ammonium means the ammonium chloride is the strong electrolyte, that's why it completely dissociated, and that's why this ammonium NH4 plus and the Cl minus ions, then plus H2O that gives the, this is the weak base, only partially dissociated, therefore only that ammonium hydroxide is keep as it is, only the dissociation of strong electrolyte. Here HCl is the strong electrolyte, therefore it dissociates completely Cl minus. And you know NH4 plus, this is the ions Cl minus H2O that gives the product is the ammonium hydroxide, weak base keep as it is, and H plus ions and Cl minus ion, that means it dissociated. Therefore Cl minus ions, this Cl minus ions, Cl minus and this Cl minus, that is the cancel. Only remaining will be the ammonium ions plus H2O that gives the ammonium hydroxide and the H plus. And resultant solution is due to the presence of H plus ions, means large number of H plus ions, and therefore that solution which become the strong acid. Strong acid. This is the strong acid. And you know, according to the definition of hydrolysis, hydrolysis is nothing but the cations. These cations or anions that contain the not anions. Only cations or the anions combines with the H2O, means it hydrolyzes H2O that gives the ammonium hydroxide and H plus. And this is for the hydrolysis of the second salt. An example of copper sulfate, then ammonium sulfate. These are the example of the salt of strong acid and the weak base. Then third one, or the third salt, third type of salt is salt of weak acid and strong base. Now examples are the sodium acetate, potassium cyanide, sodium carbonate. These are the important example of salt of weak acid and the strong base. Now explain this one, third one. Now let us see this CS3COONA. This is the sodium acetate, is the salt, strong salt, combines with the H2O, and that gives the acetic acid CS3COOH plus acetic acid, then a NaOH, sodium hydroxide. Now here in this hydrolysis reaction, the weak acid, this is the weak acid, acetic acid is the weak acid, and the sodium hydroxide is a strong base. With that salt, sodium acetate is a salt, formation of salt by the combination of strong base and the weak acid. This is the one example. Means the sodium acetate combines with the H2O, it hydrolyzes to formation of the strong base and the weak acid. And same, the according to the ionic theory, when any strong electrolyte is combines or the dissolved in water to produce the ions H2O, and to formation of acetic acid is the weak acid. Therefore acetic acid CS3COOH is the as it is, and only the Na plus and the OH minus ion, these are the dissociated ion or separate ions, because it is a strong one, or the strong electrolyte, NaOH, strong base. Therefore this Na plus and this Na plus, that ions are the same in a reactant and the product side. Therefore the cancel to Na plus and Na plus. Then remaining will be the CS3COO minus acetate ions and the H2O, that gives the acetic acid and the OH minus ions. This is the resultant solution, but that resultant solution that contain the number of hydroxyl ions, large number of hydroxyl ions. Therefore that resultant solution is the basic solution. Solution is the basic one. Means the according to definition of hydrolysis, when the cations, that process which cations are the anions, these are called the anions, combines with the that H2O, that is called the hydrolysis reaction, and which gives the product is the acid, product is the that which acetic acid, means acidity or alkalinity, but main actual that resultant solution is the basic one. Now this is about the third one. And last type of hydrolysis of salt is the salt of, or salt derived from weak acid and the weak base. Now see here, when example is suppose the ammonium acetate CS3COO ammonium NH4, that combines with the H2O, that gives the this formation of the salt is the formation of weak acid and weak base. Therefore ammonium acetate combines with the water to formation of the acetic acid, that is a weak acid, and the weak base, that is ammonium hydroxide. This is the weak base and this is the weak acid. Mean that salt ammonium acetate is a salt of the weak acid acetic acid and the weak base ammonium hydroxide. And then according to that ionic theory, Then whenever this strong electrolyte, here strong electrolyte is sodium ammonium acetate. It is a strong electrolyte which dissociate, means formation of CS3CO minus, then plus ammonium ions, because it is a strong one, that's why it dissociated, then plus H2O, and that gives the acetic acid, keep as it is, because this is a weak acid, and also weak base also, that keep as it is means remains same. Therefore this resultant solution or this weak acid and the weak base, means this is called the hydrolysis reaction. Hydrolysis reaction. Now this resultant solution is the either the acidic solution or the basic solution. Resultant solution is the acidic one or the basic one, or sometimes the neutral one. For salt of the strong acid, salt of weak acid and the weak base. And according to the hydrolysis reaction, this fourth example is the process in which the cations or the anions combines with the water to produce the acidity or the basicity in the solution, is known as the hydrolysis of salt. Now this is about the hydrolysis and the types of hydrolysis. Okay, if any doubt about this one, now these are the four types. Sometime out of these four types in your annual exam, which carry the 2 marks, explain the salt of strong acid and the strong base. Explain, or in this first one, why the salt of strong acid and strong base does not hydrolyze. You have to explain. Then at least the example right now which carries the marks, or explain the salt of strong acid and weak base, explain weak acid, strong base, and last with the weak acid and a weak base. Now this is about the types of salt. Okay, is any difficulty? No? Yes? Anybody? Okay, understood? Okay, okay, right.